Hey, everybody, and welcome to another episode of Adventures in Machine Learning. This week on our panel, we have Gant Laborde.
Hello.
I'm Charles Max Wood from devchat.tv. And this week we have a special guest, and that's Daniel Svoboda. Did I get close on that?
Svoboda, yeah.
Cool. Do you want to introduce yourself real quick? Let everybody know why you're important.
Yeah. So I am right now a data scientist at Verizon. My background is from Stevens Institute of Technology. I have both my bachelor's and master's there. My master's in machine learning. So I've worked a variety of jobs in top companies, including like S&P Capital IQ, Bank of America, AT&T. My background has been machine learning, deep learning, and has now been increasingly more and more natural language processing. My interests have always been in understanding like other cultures, history, and linguistics. So when I got into machine learning, I found out about NLP, and I found it was like a natural fit for me given my prior interests.
Are you a software engineer trying to learn machine learning? Then you should check out the course from educative.io called Machine Learning for Software Engineers. It has 87 lessons, 8 quizzes, 115 challenges, 163 playgrounds, and 2 code snippets. In other words, it's not just a set of videos that tell you how to do the thing. It actually walks you through all of the processes for machine learning. It gives you quizzes, it makes you do challenges, it's very hands-on, it's done with experts from companies like Google, Microsoft, Amazon, and Apple, and it is a terrific course that I've been learning to do machine learning. So go check it out at devchat.tv/learnml. That's devchat.tv/learnml, and that'll take you to the right place so you can sign up for the course. All right, I got to stop you because you used the slang term NLP.
Right.
What is NLP for people?
It means natural language processing.
Okay. Can you give us an example of how it's used?
Yeah, so there's a lot of things. For example, sentiment analysis. People will have like, let's say, tweeting. If there's an uproar about something politically going on, people will make like, how would I say, like, incessant ranting, and the NLP can automatically classify as like very angry, partially angry. So it can go along more of like a spectrum of sentiments, like from neutral to positive emotion to very heavily negative emotion. Another one would be like document summarization, where you have documents and, sometimes in our age, people are very busy and they want the Cliff Notes version. So if you train an algorithm, it will find like either the most relevant sentences and publish that so you get an idea. Or in some of the newer versions of NLP, they'll generate its own sentences, and the sentences will be succinct regarding the topic. For more of like what's going on in everyday life, when you're going to technical support, you're going on the chatbots. So chatbots are definitely NLP. They work more and more by text data, whereas in the past with NLP, you would be writing like a program and writing if-else constructs. Mm-hmm. Everything is basically trained by data. And especially now in the age of deep learning, we're getting much, much more fantastic results, and that we're basically able to pick up more of the subtle nuances of linguistics, which in itself is very fascinating because linguistics is a very, very slippery subject. I would say it's both an art and a science. There's the science of analyzing the statistics and forming the formal rules. But it's also an art because, you're reading literature. Everything is basically subjective in how you look at the words. So there's like a lot of subtle nuances and grasps that people can pick up, but computers can hardly pick up. And this is actually the big thing that people are hoping computers can do. Because if computers can pass the Turing test, meaning it can be able to understand a conversation as a normal person does, then basically computers are now people. They're as intelligent as people. So
yeah,
nice.
Wow.
I could write sentiment analysis for Twitter. Angry.
It always returns angry.
No, if somebody mentions a politician, it returns irate.
There you go. That's true. That's been especially that's the 2020 algorithm for sure.
Yeah.
And what's really cool about this is, people probably don't understand, or some people might not understand that, AI being applied to images, AI being applied to sound, AI being applied to chemicals, and AI being applied to words like you're talking about here. The structures are so unique because those mediums are so unique. And so, just because we're seeing these advancements on one side, now we have to figure out, do they come over into another or something like that? Because I know that specifically, each of these concepts seems to be borrowing from one another. So you're saying that you work a lot with NLP now. Is that something where, would you say, in all the different branches of what machine learning and deep learning can do, how is that doing in compared to, let's say, something like computer vision?
So I would honestly say that NLP is dragging behind a little bit in computer vision, because when you have a video or when you have a picture, a lot of things, and I'm not a computer vision expert, but I have some ideas of what's going on. People try to look at the faces, they try to identify maybe possibly the emotions, or, they keep track of people. And that honestly, I think, is relatively easy. I mean, it's not easy, but relatively easy in terms of the deep learning and machine learning field, because you basically program all these sets of parameters, like motion detection, pixel change. As long as you find the right variables and train it up, you're going to get reasonably accurate things in computer vision. And just as a side note, it's now so scarily accurate. Amazon, they're building their own Prime stores where instead of people using their credit card, if you have an Amazon account, you just go in, the cameras.
Oh, yeah.
Yeah. They can track what you're taking off and what you're putting back on the shelf. And then you just simply go out and Amazon will automatically debit. And as a side note here, when the riots were going on, a couple of people had tried to loot the Prime stores, and then they were suddenly shocked, with the bills they got, because the cameras.
That's awesome.
Yeah,
that's very funny.
I've been in one of those stores in Seattle, and it's kind of weird. They have somebody there, they have an employee there, but they're just there to help you and basically do tech support. Right? So I walked in and they're like, do you have an account? Are you set up for the walk in, pick something up and walk out? And I wasn't. So they were there to help me do that, basically.
Wow. Yeah. So that's ridiculously cool. It's really easy. You were talking about all the different applications, like catching faces, watching stuff go on.
Yeah.
I'll tell you this, with NLP, or machine learning and deep learning towards text, what are the different things that are really hot right now in that field? You were talking about sentiment analysis as one of them. So what other things would people sort of jump into lots of NLP for? They're trying to solve a problem.
So, for example, there's now building ontologies, for example. So in banks, for example.
That's a $5 word. What's an ontology?
Ontology is basically to give a layman's term, the vocabulary you use in an inside group. So,
okay.
You're in a Dungeons and Dragons meetup. You're going to have your own ontology.
You saw my books behind me or something, I think.
Yeah.
And Daniel casts magic missile.
Yeah, and if you're a Star Wars fan, you're saying words like the Force. You're having your own ontology there. So maybe I would say it's roughly equivalent to private language and things like that. So
gotcha.
In banks right now, for example, fraud detection is now becoming increasingly popular. So a lot of security experts, they work back and forth with the banks, and they have a lot of domain information. So it's to go off a side note. When you're a data scientist, you always have to work with domain knowledge. So, sometimes as an NLP person, you're working with the linguist, because the linguist will know the specific vocabulary and what to watch out for training. So, Wikipedia is the ontology, the one ontology to rule them all. That's usually for training everything. So there's a lot of algorithms. Like one of the recent
Hmm.
ones is graph neural networks, which works like a neural network, but takes the graph structure into account. So you have like all your words that are connected as a graph, like with distances.
Yep.
And then they're able to like, do classification of what the person is talking about, what the words are meaning, what is the context of the conversation. So that's one example. Like another example is question answering. So, I write out a question and, you get an answer. This has
Hmm.
been actually a thing that's been going on for a long, long time. NLP actually is very old. It's been dated back to the 1950s. Like
Hmm.
everyone had that rush of the computer age where we have computers. Oh my God, we're gonna, be in the singularity already. And then he said, all we got to do is just get these part of speech tags and we're golden. Computers are people.
Right.
And they turned out that it was not that simple.
Yeah.
But now, because of more and more evolving art, NLP has come to the forefront, especially now with machine learning and deep learning, probably since the 2010s, I would say, more and more. And as a side note, I would say what's been really, really driving this is the big data revolution. So,
Hmm.
Oh, yeah.
everyone now has the ability to, using Hadoop or Spark to train so much data. And that's why we're getting fantastic results. It's a lot of the algorithms have actually been around for a long time, but it's just the ability to process data so
Yeah.
much and very quickly that we've been able to get these fantastic results. So going back to the question answering, in the 60s and 70s, there was actually a famous program called ELIZA, where they were trying to
Mhm.
use principles of psychology, where someone would ask a question, they would parse the words, or they would get the sentence, and they would use that like whole sentence or parts of the words and then reformulate another question. And it sounds very dumb, but they actually did get like a lot of results that most people could understand most of the time. And but now with question answering, because deep learning is now able to get the subtle nuances, more and more they're able to formulate like the right type of answer for the question that a person is looking for, something that is pertinent to the conversation. It's still an ongoing art, because if you try to have a conversation, after 3 or 4 sentences you like lose the context of the
Hmm.
conversation. And that gets back to the very slippery art of linguistics,
Hmm.
because unless you're in the know for the group, at some point you're going to lose track, but person who is very well aware of, you know, the ontology or the going on to the group, they're able to follow all those social nuances.
Huh.
That's the way
That's
why linguistics is a slippery art, because, it's very, very private language, Star Wars geeks may not necessarily what's going on with the Star Trek geeks, for example.
hey, I think they joined teams at some point. Here, I'm not sure. I think that the feud is finally over. And plus, don't forget how Gandalf said, "Use the Force, Harry Potter." So, uh, but what, what I will say is that is really cool. And using it to have a conversation, I think there's always been a lot of money behind that. Chatbots, right? I think a lot of people are looking towards chatbots now, and they're using things like BERT, which if you want to chat about, and I don't know a lot about this, but it seems like GPT 2 came out, and then there's this giant hoopla about this marketing is like it's too dangerous to release to the world. We can't have all this generative text. So, would you say that sort of that chatbot thing? People are probably using BERT. Like how is that coming along? Are we a few years away from people being able to set up a chatbot to basically do customer support? Are we 5 years away, a decade away? What's your thoughts on any of those crazy things that people are coming out with, or is it all hype? Is GPT 2 and 3 not dangerous for the world?
I mean, honestly, I think it's too early to tell, and the reason why is that a lot of these discoveries, BERT, GPT, they're coming out from DeepMind, from Google. Google is basically like the genius laboratory where They
Mhm.
are coming out with all these ideas now, open sourcing it, and then I think it's up for the companies or for people to individually use it. If you are a Kaggle person, and Kaggle is like the site where, companies and people publish data, and they allow people to like go online and, work out all the algorithms, the feature engineering. Sometimes it's basically the equivalent to what is open source to program. You know, Open source,
Mhm.
there's all the GitHubs with the codes you can download. Kaggle is maybe what the equivalent for data scientists, except that it's not only code, but methods of what people do. And I consider myself well seasoned data scientist, but
Mhm.
there's always more and more techniques you're going to find all the time. Like, I get a problem, I'm going to be stuck, and I go on Kaggle, and someone will come up with an innovative solution, and I go, why didn't I think of that?
It's the Stack Overflow. Yeah.
Exactly.
Awesome.
But I do know, because I had interviewed in the past for a couple companies. There's a lot of startups right now that are trying to take advantage of the chatbot revolution,
Mhm.
whether it's like, putting chatbots for other companies or making it for a very specific purpose. They are definitely coming out with a lot of innovative ideas. And I'll give you one example. A while back, when I was in between jobs, there was a startup where they were trying to market a chatbot for job interviewers. And job interviewers, it's one of the huge headaches because, computer science people, technical people, they have to work with HR, because HR is usually the type of people who formulate the job descriptions that they're looking for. And unless the computer scientist is, easily available to look through all the resumes, they get all filtered through HR. And HR people, usually they're not going to be technically minded. So they might
Mhm.
accidentally throw out, some people who actually might have been very relevant for the job. Maybe a job description, for example, will say, oh, we need 8 years of someone with Scala. And someone comes with a resume and they have 10 years of Java. And the
Mhm.
HR person will just throw
Mhm.
that out. But the computer science person would say, well, wait a minute, this guy looks like he could work for us because, Scala and
Yeah.
Java are both JVM languages.
Yeah.
So the idea was that they wanted to create a chatbot where in the first round interview, you were physically communicating with a chatbot, and the chatbot would ask you all these relevant questions. So they would parse things relevant for jobs. They could possibly use things like synonym detectors. If you're saying you have Java, how close is that to Scala, for example? If they go to those personal questions, maybe there's like sentiment analysis, syntax analysis to say, like, is this guy sufficiently enthusiastic about the position we're looking for example? So I think right now we are in a stage of it's too early to tell. And it's mainly because so much more advances have come out before companies can adopt it. When you work in a big company, the thing is that they go through a lot of review processes. So usually they're behind the curve unless their competitors really get behind it. And then at that point, they start to speed up in using the data science methodology. So I'll give you an example. Bank of America, they tend to be very conservative, and banks are very, very conservative because, you're dealing with people's customer accounts. They don't want to take risks. They're very, very careful about their reputations. But when their competitors had started using machine learning, they wanted to get on the bandwagon with it.
Yeah. 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 Nice. By the way, when you mentioned a person who's interviewing first has to talk to a bot, there's this game called Portal,
Mhm.
and they had these posters all throughout the game that says "Know your paradoxes."
Yeah, yeah, yeah,
Do you remember that? It's like if you get attacked by a rogue AI, stand still and scream, "This statement is false," to go ahead and break the AI.
yeah.
So honestly, if I were ever in an interview with a bot, that'd be the first thing I say to it. Probably would not get that job at all. I don't think so. That's a really cool application. I think that it's really easy to come up with well, at least for me. It's really easy to come up with visual applications of AI, but I know that they're using it in smell, like to detect if a food is tasty. They're using it in medicine. And using it in language is such a cool application, but I always have a little bit more trouble. That's why I love the examples like you're talking about.
Mm,
Have a first round of interviews to make sure a person hits a certain skill set. That's a great idea. Or being able to read resume. I heard that they can read law books now
mhm.
to see like if a contract is valid or not. Just really, really, the idea of being able to read and take that information is amazing.
Mhm. I
It's
mean, that
Well,
mind-blowing.
and they evaluate it at speeds that are just, it'd take an
Right.
attorney an hour, right? Or 2
Yeah.
hours or however long.
I heard one thing is that they caught mistakes that the top attorneys in the world couldn't catch on stuff like that. So weirdly enough, we might end up in a very new legal system where lawyers are feeding contracts straight into AI, which means that all contracts need to start with this statement is false. That's all I'm saying. Uh,
What are you working on this morning? I'm programming my legal counsel.
right. So I guess like one of the things that kind of comes along is that you were talking about all this big data, right? This big data and training, Hadoop and Spark. One of the ways we've kind of gotten around, having to have clusters sitting there at Google is transfer learning for images. What's your thoughts on using transfer learning for NLP?
Okay, you used another slang term, transfer learning.
Oh, yep. Actually, Daniel, you want to take it?
Yeah. So transfer learning is where you have predetermined architectures, complex architectures that have known to work. And this is something that actually has been straight adopted from computer vision. And this actually is a new revolutionary thing for NLP because when transfer learning came out, they had like 60, 70 layers of convolutional networks. Go briefly, convolutional networks are the type of neural networks that are adapted best for reading images. And when that came out, that started generating these really huge advances in computer vision. So everyone was saying, oh, if we can do this, why can't we do this for NLP? But for a couple of years, there was sort of like a standstill because everyone had tried to take like the architectures from computer vision, but they got like limited results in
Right.
natural language processing because
Mhm.
what works for images does not necessarily, work for languages. I can give you one good example. Computer vision, they're based on state, like what one pixel is to another pixel. And, these type of neural networks, what's called convolutional neural networks, they're adapted because they go from like, they're based on the position, all the positioning of the pixels. And there are some things in languages that do work with position, but not necessarily.
Mhm.
So there is another type of architecture in NLP called LSTMs, long short-term memory.
Yep.
And they're what's called state space. And state space, that's how you hear everything. Like right now, what I'm talking, you're hanging on to every word that I say. And, the way that you're going to react is going to be basically based on how I'm saying the next word and so on. If I suddenly said like, like a curse word to you, then you're just going to like pop out because that was completely unexpected, because
Right.
there is the flow of the conversation. And then suddenly if I'm popping something out, that is like completely out of the context, so you're trying
Yeah.
to learn exactly within the context. So, but there has been now some discoveries as of late
Mhm.
after some scientists at Google came out with the transformer and the BERT architecture. So they have premiered these architectures which are specifically made for NLP, and they have been getting really, really great advances. So one example is the BERT architecture, which
Mhm.
is trained on sentences. And to give you a bit of a background, NLP has had before was the word to vec and glove. That was actually a revolution in itself because what they did was they had neural networks that you would take like a certain amount of words, like let's say 7 words, 9 words from a sentence in paragraphs. You train on like, you'd hide one word, but you'd have like the first three and the last three words. And then you would have the architecture pick up like, what is that hidden word it's trying to predict? So there's a lot of fancy architecture and so on. But the short story is that it was a groundbreaking revelation in itself because it was able to pick up the syntax of a sentence. So we were talking about ontologies before. If I took all these paragraphs on Wikipedia, maybe on Star Wars, and trained Word2Vec, you would get like the semantic meaning. So one example would be like if you computed the numerical vectors, which are the end results of these, and you had the numerical vectors for like king, queen, man, and woman, then if you did like, an analogy like man is the king as woman is the queen, if you did these numerical operations, they would actually map out the same. So you're actually preserving the syntax. So BERT is a huge advancement in that because now we're stepping up the scale. Instead of just individual words, now you have the ability of sentences to be transcribed into numerical vectors. And so that was like, there's such huge possibilities there. So if I'm entering a search engine and I want to say like, bring me up, sites on Star Wars, then not only would it do that, but it would look at very similar queries, and it can, do cosine analysis to find very, very similar queries or similar websites. So it has the potential of like getting down for search engines to be much more accurate than possible.
Very cool. Yeah.
Nice. Leveling up is important. I spend at least an hour every day learning ways I can improve my business or take a break and listen to a good book. If you're looking to level up, I recommend you start out with the 12-week year as a system to plan out where you want to end up and how to get the results you want. You can get it free by going to audibletrial.com/code. That's audibletrial.com/code.
So I have an off-key question here. You mentioned a lot of Star Wars and Star Trek.
Yeah.
Which makes me wonder, was that a huge inspiration for you getting into being a data scientist? Or like what was sort of the story of you getting involved in that? Because I can see, it's obviously influenced you. And I don't know if that's sort of like what started this whole thing, because it's an advanced thing. And I wonder how people kind of get started on stuff like this.
It's a funny thing because when I was watching Star Wars and Star Trek, they had the artificial intelligences, bots. That never came first to my mind. What came first to my mind was everyone going at warp speed and able to travel at other planets. So in another, with the other right influences, maybe I could have tried to gone into physics and find, the next warp engine. But realistically,
I'm still waiting.
Yeah, airplane flights still suck.
Bring back the Concorde. We could go back to that step in order to like make the next step from there.
Yeah.
But my interest when I was at college, I was hugely into computer programming, math, and funny enough, history.
Oh, okay, yeah.
I would tell people those interests, and they would say, like, well, that's like an odd combination,
Yep.
So, I initially had been ambling around, and I was very interested in mathematics. So I had studied computer engineering, and I was interested in computer engineering stuff that was more towards the mathematical side. So initially, I wanted to work in image processing, and when I had gone back for my master's, I was taking classes towards it. My advisor, like when I went to him, asking what classes I should take, he one day said, you need to take machine learning because that is an up and coming subject. So I took it, and I don't know if anyone has like these out of the bolt blue insights, it's like when you want to say in your mind metaphorically, eureka. That's what happened.
Yeah. Yep.
It was just such an awesome subject. I mean, the fact that you could use all these modern algorithms and predict things, that I just went to my advisor. I said, okay, I'm switching my concentration from image processing to this, to
wow,
machine learning. But so I had gone into machine learning, but machine learning, I would call it a meta subject because it's a list of techniques, but you need to specialize in a certain area how you're going to use machine learning. So there is computer vision, there is recommendation systems, what's driving your choices for Netflix and Amazon and so on. So there are all these wide areas. And for a bit, I had worked at a company where I was planning to do image processing with machine learning. But then after that, the company was not doing well. They had to lay off their workforce, and I was out on the market again. And I went as a contractor to Standard and Poor's, and they put me on this natural language processing, and that was my eureka moment. And I found out how natural language processing is really tied into linguistics. It doesn't sound like history and linguistics are very similar, but in many, many ways they are. Because when you study history, if you're studying the history of France or Germany, you see how their languages evolved over time and how they have their own concepts. So there was sort of a short leap from history to linguistics, and then from linguistics to natural language processing. So if anyone is trying to get into machine learning and trying to find their own interest, I would say, think what your other interests are and see what other subject could really fit into that,
Very nice. Awesome.
Yeah, makes sense. And it's interesting too. I mean, you're talking about, again, the natural language processing, and you're talking about history and things like that. And yeah, I mean, when we talk about World War II, for example, and this is just an example, my wife's she'll watch any special that has anything to do with World War II. And what's interesting is that a lot of it comes out of, the perspective of, when the US got into the war, and then, storming the beaches of Normandy and things like that, right? Because that's where our troops from the US, were heavily involved, Pearl Harbor and things like that. But yeah, if you go over to Germany and you talk about the history of World War II, they're going to talk about the rise of the Third Reich, and that's going to be much more of a focus, and how it happened and why it happened and what was going on and what sort of the national mindset was, and then how it was overcome and how they rebuilt, and all of that stuff. And so it's a different thing, and how Germany got divided between the Soviets and the US, right? And so yeah, it's a different mindset. And so we're talking about the same things. We're actually using a lot of the same words, but our thought process about it is different, and that changes the meaning of what we're talking about.
Yeah. It's always from a perspective, and I think that's with it, I think it's good that the cross pollination of those concepts, we see that in machine learning as well. You're looking at they're trying to apply something here, and you were saying some of the breakthroughs that happen. But each of these things, I think, coming in interested in math and history, that was going to land you in those eureka moments that they're specific for you. And I think like that each of us are still trying to find those. Yeah, that's the thing. I think life is just us all trying to find our next eureka moment. It's a kind of an interesting perspective, combining that. What's our World War story?
Yep.
I guess since you've been in this field for a bit, is there anything that you want to talk about with NLP that might be really interesting, that people should understand the mechanics of? If someone were okay, this episode was my eureka moment. I want to use NLP to do this. Not what kind of first steps, or what's the hot technology that they should be kind of checking out in order to advance in that field?
So I think that's a very good question. And I would say this, how I tried to learn myself. Initially, I had found books, I had found research papers, and I had Stanford, for example, they have open source their lectures on, YouTube for natural language processing. So they have two classes. One is the straight natural language processing, which goes into all the theories about linguistics, like morphologies, syntaxes. And then they have the deep learning class where they go more into like the deep learning architectures, like what deep learning is and what architectures have worked best in deep learning. But honestly, I just got so much into it that literally I then had to force myself to start practice programming. And when I started practice programming, I honestly learned a lot more than I did just reading the theory. So, number one, I would definitely say instead of manically trying to read everything, start programming first. So, some of the popular libraries are NLTK. NLTK is a natural language toolkit for Python. And it's basically the original and kind of like the gold standard. I would say browse the APIs. Another one is called Spacey, and that is relatively new. And Spacey has a lot of functionalities from NLTK, but they also have some newer technologies. Some of them are being able to incorporate like the architectures from transfer learning, for example, downloading like architectures online. And it's really more modern because they have the same things you would find in NLTK, like part of speech taggers, phrase chunkers, but they use deep learning techniques in order to parse them out. Whereas NLTK uses like the more old established statistical methods. So one of the things I would say, and sorry to go off on a tangent, a lot of times people, when they try to get into machine learning and natural language processing, they get very, very disenchanted because unlike computer programming, you just learn C++, you learn data structures and algorithms, and then you're all set to go. Machine learning, there's so many variety of subjects. There's linear algebra, there's calculus, there's optimization, probability, statistics. And some people just give up because they feel like they're so lost in the weeds with all these complex subjects they have to start. But I would say start, going through the APIs, understand the fundamental techniques of how to get data and how to clean data. So cleaning data is stemming, lemmatization, phrase chunking, getting part of speech tags. Learn how to use like the basic machine learning or deep learning libraries like sklearn, deep learning, Keras. Just learn how to put your data in, analyze your data. I think like the first step that breaks all barriers is just learn how to like parse text, put it into a machine learning algorithm and see what your results are. And, sometimes people just see like, oh, this is so cool. I got like a 90% accuracy, and I'm already able to like predict this. And then once you're there, you're hooked in. And then, from there, like I would say start working on individual projects. I had mentioned Kaggle. Go on Kaggle, look at what data sets are out there, what people have done, gain your ideas. I would say start from a practical oriented approach and go more to the theoretical. Like when you're starting to work, like let's say with language models, when you want to like make generative text on Harry Potter, then like when you get into that, then I would say once you get the practicality down, go to like YouTube or go to Coursera and look at like how language models work. So then you understand the theory, and then that will probably put a little bit more color into like the lines that you've drawn in your painting.
Nice. Yeah. I could tell you I'm at step one of that. I've taken the language of a podcast once and I ran it through and I got 30% accuracy for generating what's coming up next. It is terrible.
Yeah.
I was like, if I take all this podcast text, can I generate an entire podcast? I tell you what, I can generate something that sounds like beat poetry. Just nonsensical words that come out from previous podcast episodes. But to your point, I learned a ton. I had fun doing it. And I think that helps me out get to the next level on that. But I think it is fair to say where NLP is, it is a multi-book series to get to somewhere where you can have some serious application. Hopefully that's going to change. I mean, I feel like all this always starts that way. Like begin the saga to be able to finally make something useful. And then that always gets condensed to a For Dummies book where you can kind of knock it out pretty fast. I don't know how far away that is, but I really enjoyed the process, but also at the same time, I always want the product.
And I have to say, I don't feel threatened then if you can't generate a podcast without me.
No. I really wonder if I took all the text from all these podcasts and then I had it generate stuff, what kind of insanity would come out of something? That I'm excited. This might be my next thing.
Scared.
Maybe I'll use. Well, actually, Daniel will tell me what to use, and then I'll put it in there.
Yeah. See, now I'm scared. Is that what I sound like? This is unintelligible. Anyway,
I like this idea because it doesn't. No one's going to blame the algorithm. They'll just blame Chuck. So perfect.
Yeah.
That's really cool, though. Is that what you kind of work with every day, like a high level concept? Or, I mean, I'm sure you can't tell us too much about what you work with every day, or are you generally find yourself fine tuning something that already works?
I mean, when you're working with data science, I would say it's definitely a science. And when I went from programming to data science, it definitely was a big shift in my paradigm because when you're doing programming, you're writing code, something goes wrong, you're debugging line by line, and, you might have to revise like a function block or a class block, but nothing really so major. But when you're dealing with data science, it really is like a science. And, I pride myself on like knowing math, but there's a difference between like, let's say knowing math and having to do science. When people do science, they do the scientific method, problem, hypothesis, procedure, observations, conclusion. So I would say you have to be something of a bit more mindful because if you're doing everything naively initially, one of the naive ways when you're doing machine learning is you're taking all these models, you're doing ground testing, you're checking like what are the accuracies. Then you might say, okay, out of all these models, the support vector machine has worked the best, and then you take the support vector machine and you're fine tuning the margin window and all these other parameters. You're trying to prevent overfitting. So it's like all these multi-label things you have to keep track of. And sometimes it can be a bit frustrating because, you do all this effort, but still you're only getting 60, 70% accuracy. Then you have to figure out, I did as much as I could. I need more data or I need more features. Sometimes you'll have to say, I'm sorry, we can't get more accuracy, but we seem to see like a lot of descriptive things with these variables here and here. We're seeing really good things with these features, but we're not seeing good things with these features. Maybe we need to do feature engineering and extract more and more of these variables. So, you look at the results and you say like, okay, this is doing well, but it's not doing well here. So maybe there is like a model that is known to do better with these things. And then that's before we even get into the techniques of like, let's say ensembling models where you're working with multiple models that are going to work well. And you're throwing them in like to see if they're going to up your classification. So I definitely would say it's a much, much more multi-dimensional way of thinking. And in many ways, I'm still getting up to speed to it as well. And I would say a lot of scientists, not just data science, but, in chemistry, in physics, it's an evolving art for them because they get to be domain experts. They have to gradually know what works here and here, refining their processes. It's probably like, for example, why when you see Nobel Prize winners in chemistry, a lot of the people who get them are in their 60s or 70s. And that's because they worked up a lifetime of getting knowledge in order to make like the right breakthrough that got them that prize, for example.
Yeah. It's surprisingly an interesting industry because, there's very few places. And that's a true science because there's very few places where you could say, hey, we tried to build this. It currently can't be built. We have to go back to the drawing board. And, there are entire industries where someone comes in and says, hey, I want to have a model that does this. And they have to put a lot of money forward, and they could possibly at the end of it come back with, sorry, it can't be done with what we have. It's really cool that we're still, we're able to do that, and that we could still actively invest in science that way. Because a lot of people will not put money forward for things like that anymore.
Yeah, well, the other thing that's interesting there, and I wouldn't be shocked at all if we see the same kinds of discoveries in machine learning, and that is that a lot of times what happens is somebody theorizes, okay, well, we could make a better model doing this, that, or the other, and then they somehow make a mistake, right? And the mistake is, oh, wow, now we're getting a 90% success rate, right? And so then they go do the work to prove it's not a fluke, and it turns out that mistake was the breakthrough, right?
Oh,
And
wow, yeah.
It happens quite a bit, and usually it's with, or we've seen a lot more of this in chemistry or in some of the more physical sciences. But at the same time, I mean, it's like, oh, well, this is a consistent result over and over and over again. So it, and then we advance.
Yeah. Yeah.
Anyway, we're kind of getting toward the end of our time. Daniel, if people want to connect with you online, where are the best places for them to do that?
Yes, so you could connect with me, I guess, through my email, which is my first name, daniel.svoboda@gmail.com. I think I also have a LinkedIn account. I mean, I can send that as well. It should be under my name. So, people could either message me, but I think probably by email would be more preferential.
Awesome. All right. Well, we're going to go ahead and deviate into our final segment, which is picks. And picks are just great stuff that you're enjoying in life. So a lot of times folks will pick books or movies or things like that. Sometimes they pick tech or tech tools, and sometimes it's just, whatever. So Gant, why don't you go ahead and start us off?
I've got a pick here that is specifically, this is an exclusive for our listening audience, is that, I get asked, how do I get started in AI over and over and over again? Funny enough, I was like, I should write this down. So I made a flow chart of if you're interested in one thing or another, if you know that you're ultimately going to go into, you want to study the mathematics of it, showing what courses I've taken and other people have also approved of. Or if you just want to get there to building something, if you want a crash course, it'll point you towards that one. So I made a flow chart, and it is at bit.ly, that's bit.ly/AI quick start, all one word, all lowercase. I'll put it in the show notes there as well, so that you can click on it. So yeah, that flow chart just basically says, hey, what is it that you actually want to do? And once you know what you want to do, it tells you, all right, go take this Coursera course because I took it and a bunch of other people say it's great. Or go read this book. So I got sick of answering the same question. I made a flow chart out of it. And it's beautiful. I think it's really cool. And anybody listening, that link's only being given out here on the podcast.
Awesome. I'm going to throw in some picks. Now, I've been spending a lot of time on marketing lately.
The evil secret arts.
Yeah. We should compare notes since you do a lot of the marketing for Red. But yeah, I've gotten into Russell Brunson's materials lately. So I did the One Funnel Away challenge, which was awesome if you're getting into marketing. And I'm just going to pick his books. He has .com secrets, expert secrets, and traffic secrets. And it basically just breaks down how to set up marketing funnels, how to build products and build movements. That's what expert secrets is about. And then traffic secrets is, how to run traffic to your funnels. And anyway, it's great stuff. And I'm really, really enjoying everything that I've been getting from it. I also went to their live online summit and a bunch of other stuff. So I'm excited about that as well. And then I've started rereading the Wheel of Time books, or listening to them on Audible. And
nice.
Those are great books by Robert Jordan. Brandon Sanderson finished them off, wrote the last 3 of them off of Robert Jordan's notes. But yeah, they're great. I really, really have enjoyed those books over the years. And so I'm going to pick those as well. Daniel, do you have some picks?
Yeah. So in terms of shows, I've been referencing Star Wars and Star Trek a lot. And part of it is because I've been watching now recently Star Trek Picard, which is on CBS All Access. And it's really, really blown my mind away. And I was really surprised because the Star Trek, like from the Next Generation to Enterprise, that was like Next Generation, Deep Space Nine, Voyager, Enterprise. They, they had slightly different storylines, but they started to follow into the same formulas. And I suspect that's why people started getting very tired of Star Trek Enterprise, because it was just very, very formulaic. Like they tried to, of course, do some things that they think they didn't do before, but it still was very formulaic. And Picard is completely a new paradigm on how they do Star Trek. I mean, they must have taken a cue from like how they ramped it up, with the new Star Trek movies. Picard is like, they make like a much more complex storyline that was simply in Star Trek. Like everyone, in the Next Generation, they're shown to be like, all Renaissance men. Everyone knows Shakespeare. Everyone is able to quote all these books. That was supposed to be like our highest ideal. And, with Picard, they show that, but they show like a lot more complexity that, makes it more believable, and less staged. So I think it's really, really exciting. And it's coming out with like new ideas on how maybe future Star Treks are going to come down. What I'm reading right now is a book called Range by Dave Epstein. And it's a really, really interesting psychology book. So it blows away the paradigms on how people think they're supposed to become experts. So usually the idea, if people think they want to become like a math expert or computer science expert, is that from the age of 3, you're drilling down everything. You're learning nothing but math all the time. But the research shows that people who have a wide variety of different subjects, like, a little bit of psychology, a little bit of math, a little bit of data science, computer programming, that actually is not only as good as learning a very specific subject, but it's even much more preferable. And the reason why is because when you've learned all these different subjects in history, in linguistics, they have their own paradigms, their own metaphors. So when you learn a new subject, say math, you could actually use the paradigms in history and linguistics in order to learn like new math subjects, for example. And I think this book really, really goes into what I had said before about using your widely differing interests like math and history in order to come to the eureka moment of what you're interested in. So I think that book, not only interesting in itself with the latest research in psychology, neuroscience, it would help people to figure out what they want to do and how to get to it.
I like it. It reminds me a little bit of the arguments in science that I've seen around like diverse teams and the fact that you come up with better solutions because everybody has a little bit of a different background and therefore looks at the problem a little bit differently and looks at the solution differently. And so having a wide breadth of topics that you understand, it seems like it would lend itself that way as well. Yeah, because you're looking at the different paradigms and thought processes that have been pioneered and work out in those areas to innovate in others. All right. Well, thank you, Daniel. This has been really fun. And I really enjoyed kind of diving into NLP and seeing what's going on out there. We'll go ahead and wrap this one up. And until next time, folks, max out.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.